Okay, we're in class distance learners. I'm up in your top left-hand corner. I'm going to try really hard to stay behind here so that you can see my face while I'm teaching, but I'm not sure that I'm going to do that great at that. So if you don't see me for long periods of time, please just bear with me and try to follow along with what we're doing. Okay, so for everybody, you guys now have a bag of M&Ms, and I'm going to let you do the task that's associated with that at home instead of here, because what you have to do is open it and count up how many of each of the colors that you have. So I don't really want you opening it and counting it all over on our desks just in case. Know what I'm saying? Okay, so you're gonna fill out, this is the only thing that you have to do on this bar graph paper, is fill out this relative frequency table. All you have to do is write in the color and the count, and that is it. You don't have to do anything else on the rest of the page. We'll do it when we're together on Wednesday. The one thing that I want to do together with you right now is write in the order of the colors so that when we talk about this together, our colors are in the same order. So hopefully it's a little bit quicker for you. So the first color should be orange, and I'm just following the peanuts. Those aren't peanuts. The M&Ms down here, I'm trying to follow their color. So orange would be your first one. Then I think the next guy is red. Then yellow, green, blue, brown. And then once you open them and count them up, they're yours, and you can do with them whatever you would like, which is probably to eat them. I think on my notes, I'm gonna keep track of what we're doing by putting the date in the corner. So we're gonna finish this on 9/2. That's why I'm writing 9/2 there. Shelby, do you want to take them their activity for the day? Shelby's gonna bring you what we're actually doing today. So on that paper, I would put 8:31. That's this guy, 8:31. And then the types of data paper is 8:27. You don't have to do that, but if I do any kind of organizational thing to keep my stuff in order, I try to share that with you guys so that you can do that as well if you would like. So the first part of what you're doing at home between now and Wednesday is counting up the colors of your M&Ms. And then you don't need to bring them back or anything. You're good. Okay, so while Shelby's bringing around your activity for the day, let's talk about what you were supposed to do last time. I was telling Shelby as you guys were walking in that I'm pretty sure I had the stomach flu or food poisoning or something, but because some of the symptoms are so similar to COVID, they recommended that I stay home until I got more symptoms or felt better. So by Thursday afternoon, I felt better. So hopefully you're not worried that I'm going to pass on any Goombas to you guys. I think I'm better now. So, but while you were gone, you were supposed to get into Canvas on the day 8/27 and watch all of the videos that were there. Before I forget, did you guys have any questions on the grading video? If you did, you probably don't remember. Georgia asked a really great question. She asked if you guys can redo assessments for this class, and you can. You can always redo them. We want to get you to the point, though, where you don't have to, where you're getting the score that you want on the first try. So if you're having to redo every single quiz, we're going to have to talk about how you're studying for it. But I usually let you redo whatever you want to redo. So you can redo your quizzes, which means that ideally, if you wanted to have an A in this class at the end of the term, you should have an A in this class. The goal always is, if you're going to have an A in the class, that should translate to a passing score on the AP exam. So you have to know that if you want that A, you really got to earn that A by putting in the work and redoing things if that's what you want to do. But you were supposed to watch the grading video while I was gone and then go through and watch the lesson for this. I'll zoom out. And then you were supposed to try the ones that I have blank 2, 3, and 4 on your own. So we briefly talked about last time what we might do on Fridays. So for Fridays in this class, it is a work day. It is a day for you to do all of the practice that you are supposed to do. So like you're gonna get a little bit of practice today. You can wait to do that until Friday if you want to. We'll talk about it a little bit in class on Wednesday, but if it happens that you can't get to some of your practice problems until that Friday, that's fine with me. Friday will be your work day. That also means that's the day you should use to come in and ask questions if you have questions. You can come in, you can call me, you can email me. In Canvas, you can send me a video message, which I personally think is the easiest way to do it. So make sure that you know if we're gonna use Fridays for you to get your work done and for you to ask questions, you actually need to use that day. And I'll know if you're using it because I can check your packets to make sure that they're done, and or I can see on your quiz scores that you're scoring well. If those things aren't happening, then we're gonna transition to just doing a new lesson on that day. So you gotta use it if you want it, and if you don't use it, then we're gonna do something different. That makes sense, yeah? You're sure? Okay. So what that means is if you didn't have time to go through and watch the solutions for this categorical data packet, you can use this Friday to go back through and watch those solutions. Your first quiz, it's going to be short and it's going to be timed. It's in about 1 week. So it's on Tuesday when we come back from Labor Day. And it's going to have to do with this information and the information that you do today. So types of data and then your Parkinson's disease packet that Shelby brought you. Thanks, Lovey. When I see you guys next time, when I see you on Wednesday, I'm going to ask you some whiteboard questions having to do with this packet and this packet, just to make sure that we're all on the same page. And then you'll have the weekend to study and short quiz on Tuesday. Any questions on that? You guys feel okay? Okay, I wanted to ask you some whiteboard questions today, but this packet that we're looking at here took almost the entire period last time. Last 2B, not last 2B, 2B. So I'm not going to spend any time on that. Okay, so today what we're focusing on is this thing called evaluating a claim. And it doesn't necessarily have to do with Chapter 1 specifically. Evaluating a claim is one of the most important things that you do in stats. And if I wouldn't have been sick on Wednesday, this is what I would have had you guys do instead. I would have started with these activities because the reasoning for these activities is really important that you guys understand. And this process of evaluating a claim or gathering evidence is a really important idea in stats. So as we go through these activities, if you have any questions, please stop me and get them clarified, because like I said, this is going to be one of the most important things that you do in this class. So let's talk about what a claim is. The first claim that we're going to look at has to do with Parkinson's disease. And I looked it up last class period to make sure that I was saying the right thing. So Parkinson's disease is a brain disorder that leads to shaking, stiffness, and difficulty with walking, balance, and coordination. Parkinson's symptoms usually begin gradually and get worse over time, and as the disease progresses, many people have difficulty walking and talking. So it's not degenerative in the sense that it affects your brain and it causes you to have dementia or anything like that. It has to do with your muscles. So people that you see that shake, they typically have Parkinson's. And when it says that they lose the ability to speak, it's like being the same person that you are now, but not having the ability to communicate what you're thinking. So I'm sure just by reading those symptoms, you guys hopefully can tell that it is important to a lot of people that we try to develop a cure or an effective treatment for Parkinson's disease. So this whole activity that you're about to do has to do with this lady named Joy, who claims she can smell Parkinson's disease. So if you had me last year, you've been exposed to this activity. We're going to go in a little bit more depth this year. But so Joy's husband, she started smelling a different smell on her husband. She has a really acute sense of smell, which means she can smell things that most other people probably can't. And she couldn't figure out what it was. There's a video that goes with it, and in the video, she describes how she thought that it was because her husband wasn't showering enough. Like, he had a job where he worked a lot, and she was worried that he wasn't coming home and showering because he was so tired from work, and she thought that that's what the smell was. Well, fast forward, he gets diagnosed with Parkinson's, and she realizes she thinks that she can smell it. She thinks that what she was smelling was the disease. So that's the setup here. It says, as reported by the Washington Post, Joy Milne of Perth, UK, smelled a subtly musky odor on her husband, Les, that she had never smelled before. At first, Joy thought maybe it was just from the sweat after long hours of work. But when Les was diagnosed with Parkinson's 6 years later, Joy suspected the odor might be the result of the disease. Scientists were intrigued by Joy's claim and designed an experiment to test her ability to smell Parkinson's. Joy was presented with 12 different shirts, each worn by a different person, some who had Parkinson's and some who did not. The shirts were given to Joy in random order, and she had to decide whether each shirt was worn by a Parkinson's patient or not. So here's the whole reason that we're doing what we're about to do. Joy comes up to us and says, hey, I can smell Parkinson's disease, and at first the only thing that we can do is decide whether we believe her or not. So if somebody comes up to me and says, hey, I can smell this disease, my personal initial reaction is going to be, I don't know about that. I don't know that people can smell diseases. So the next step is, well, let's see if she can show us. Maybe if she can show us that she smells it, we'll believe her. And that's where it's headed next. She's going to do an experiment where the people wear the shirts, they put the shirts in Ziploc bags, give them to Joy. Joy opens them up, smells them one at a time, and determines whether or not she thinks that the shirt smells like Parkinson's. So the claim is Joy can smell Parkinson's, and we're going to investigate that claim. So the first question here says, how many correct decisions out of 12 would you expect Joy to make if she couldn't really smell Parkinson's and was just guessing? So how many shirts do you think she got right if she's just guessing? What do you guys think? Like 5? I'm kind of with Allie. I think that it's potentially, if she's guessing out of 12, for me personally, I'm thinking she's going to get about half right. So I'm thinking anywhere like 5, 6, 7. If you're like Allie and you say 5, write 5. You don't have to write 5, 6, 7. You write whatever makes the most sense to you. So if in your brain you think that she could only guess 2 right, you're going to write 2 there. Because in stats, a lot of the time, you're going to get questions where it simply is your opinion. There is no right or wrong answer, and this is one of them. Number 2, how many correct decisions out of 12 would it take to convince you that Joy could smell Parkinson's? So for you personally, how many would she need to get right for you to go, yeah, I believe her. She's telling the truth. She can smell it. So write down your number. For me personally, I'm saying that's all 12. In order to convince me, I'm thinking she would need to guess all of them. Maybe 11. Maybe I would be convinced on 11. So now we have the claim. She says she can smell it. Then we have one experiment where she actually tries. So we are going to simulate the experiment. So that's where we're at down here. It's called simulating the experiment. A simulation is us doing something similar to what was done. So although the researchers wanted to believe Joy, there was a chance that she may not really be able to tell Parkinson's by smell. If Joy could not really distinguish Parkinson's by smell, then she would just have been guessing which shirt was which. The researchers were not willing to commit time and resources to a larger investigation unless they could be convinced that Joy was not just guessing. So I have given you some cards to help you simulate this process. So in this cup that's at your table, this is your cup, nobody else has used it. I put them out during lunchtime. You have a stack of white cards. Unpaper clip them and shuffle them around. As you shuffle them, if you look at them, you can see that some of them have Y's on them and some of them have N's. So the shirts that have a Y are people that had Parkinson's disease. And the shirts that have an N are people that did not. Try to shuffle them pretty good. Any get white ones? Allie. Here. Yeah, you need those ones too. Keep shuffling. You want them to be as mixed up as you can. Then I'm going to go back to my dot viewer. It's weird to be behind there. Okay, so you're going to face them down away from you. And when you guess, I wouldn't look at it, because if you look hard enough, you'll be able to see what letter is there. So really try to like be honest and not cheat. And what you're going to do is you're going to guess. You're going to say, okay, I think this person had Parkinson's. It's an N, so I didn't get that one right. Okay, I think this one is a yes. Okay, I got that one right. So I start making a pile. These ones were correct. These ones weren't. You do that once, and then at the end, you're going to write down how many of these you were able to correctly identify. Does this make sense what you're doing? Are you sure? Okay, don't look at your cards. Do it without looking. Okay, I need you to, all those extra binders over there, I want you to fit as many as you can in these two things, and you stack them. So that one, this one. You stack them like that so you can fit as many. They probably won't all fit, but that's job one. And then this needs to go to the new chair coach's office.
You know where that is?
No, so you're probably going to need to check in with the front office lady, and this is a hall pass that you can use. Okay. Is 30 seconds enough? Yeah, so about 30 more seconds for you to go through and identify all your shirts. About 20. 10. 3. Okay, so I was able to get 4. You're writing down how many you got though, true? Okay, so the whole point of this simulation was or is to evaluate Joy's claim. Up here at the top, I want you to highlight this phrasing, scientists were intrigued by Joy's claim. I want it to be as clear as possible that this is what we're investigating today, different claims. So The next step says create a dot plot of the number of correct identifications with the rest of the class and record the results. So hopefully you're familiar with a dot plot from last time's lesson. If this were a different year, you guys would make a dot plot on a big poster. You'd come up and put your sticker at the correct identifications, but since we can't do that, we're just going to do it here. So first thing, label your dot plot axes down here. One of the most important things to do when you're graphing is label the axes. So we're going to label this number of correct identifications. And then the next thing that you would do is scale your axes. So what it means to scale is just to write the number on your axes. So these numbers, 0, 1, 2, all the way up to 12, represent how many you could have guessed right. So the least amount you could have guessed right is 0 and the most is 12. We can put my observation down first. So we're going to put a dot above the 4 tick mark. Now, when we start adding the rest of the dots, you want to make sure that they're the same size as this one. And you also want to make sure that up to down and left to right, they're in the same position. You don't want your dots to be in between each other. Okay, so Cheyenne, how many did you guess right? 8. Okay. Amy, 6. Priscilla, 8. Bryn, 8. Georgia, 8. Ivani, what is happening in this classroom right now? Haley, 5. Allie, 5. Grant, 8. Brooke, 6. Liz, 8. Did I already call you Liz? No. Liz, did I call you twice? No. Okay, so one thing to notice before I grab the rest is that these dots here, I'm trying to line them up left to right as best I can. And then the next one I'm trying to line up as best I can. So this guy's a little messed up now that I'm looking at it. Okay, carrying on, we need Osvaldo, 5. Aiden, 6. Aaliyah, 6. And JJ, 7. Is that everybody? Okay. So before we go on, I want to write down what we just did. So this is one simulation. This is not more than one. This is one simulation with, and then I'm going to count up our dots. I'm getting 16. With 16 trials. So this isn't 16 simulations, this is 16 trials, one simulation. So let's just recap what we've done. We are doing something similar to what Joy did. That's why it's called a simulation. And within that simulation, we did 16 trials, or we did it 16 times. So try to remember that trials means how many times you did it. They both start with a T, trials and times. Why did we do this? Well, because we're trying to evaluate Joy's claim. Can or can't she smell Parkinson's disease? So first step is she tells us. The second step is that we test her. So we can make a conclusion based off of just her one test. But what would be even more powerful is if we gathered evidence and looked at more than one test. and that's what we're doing here. These trials are our evidence against Joy's claim or for Joy's claim. So these 16 trials are either going to support that Joy is telling the truth, or they are not going to support it. We're making a little bit of sense so far? Okay, so I have a video that I'm going to show you that's going to recap this process, and then it's going to tell you how many Joy actually got right.
Joy Milne first noted something odd about her husband Cent when he was 45. Shortly afterwards, he was diagnosed with Parkinson's. Now universities are testing if it's a coincidence or a newfound precaution. Here's Mike McCarthy from our British partner, Sky News.
When she was a teenager, Joy Milne started to realise that she had an acute sense of smell. But it was only when she noticed a change in her husband Les's odour that the incredible potential of her super sense became clear.
He was an anaesthetist, he was in a close situation in theatres and he was working long hours, and I presumed, and the Parkinson's tiredness had kicked in then, but we didn't know that. And because he was so tired, I just thought, well, you're not showering enough, and I said so.
At first, Joy didn't know what the smell was until she recognised it in other people, and said so at a meeting to discuss Parkinson's.
And I thought, this is it, this is the right moment. And I stood up and said, why are we not using the smell of Parkinson's? I can smell it in this room all around me.
Now at Manchester University, researchers supported by the charity Parkinson's UK are harnessing Joy's special skill.
Once Joy's incredible ability had been recognised, she was given by the university a number of T-shirts. Now, half of them had been worn by Parkinson's sufferers, the other half by a control group. She got them all right, apart from one.
She got them all right, but one. What? Okay, sorry, I'm back. Mr. Angel was absent. I was supposed to go tell his kids what they were doing. They know now. Okay, so I don't feel like that's very, I feel like she must have been guessing really well if she was guessing. True? To guess 11 out of 12 right? Because look at ours. Out of 16 trials, did any of us get 11 right? No. Did any of us even get close to 11? No. So we're going to flip the page, and that's where this is going. So number 4 says, in the actual experiment, Joy identified 11 of the 12 shirts correctly. Based on the very small scale simulation by you and your classmates, what proportion of the simulations resulted in 11 or more correctly identified? 0 out of 16. So proportion is just a fancy word for fraction. When it says what proportion, they typically want a fraction. So let's tie this into our evaluating the claim. So we go through and we pretend like we're Joy. And if Joy was just guessing, you could expect to see results like we got on our dot plot because we were just guessing. And none of us were able to guess 11 right or even get close to 11 right. So does that support Joy's claim? Does that give evidence that she's telling the truth? Or does that not give evidence? What do you guys think? Does it make you believe her more now that you see how we did? I do. I believe it more now. None of us were even able to get close to 11. So based on the fact that 16 of us weren't able to do it, I believe that gives evidence that Joy is telling the truth. I did it with 2B. They had 25 trials. None of them were able to get 11. They got closer than we did. They had a couple of people guess 10, but even out of these guys, nobody was able to guess 11 correctly. So this does give evidence that Joy's claim is true. So let's go to number 5. Based on our simulation, is there convincing evidence that Joy can smell Parkinson's disease? So to answer this question, we have to make sure that we know what the claim is. So the claim is Joy can smell Parkinson's disease. And our response has to be based off of that claim. So notice if you look down in the body of the answer, you can see they use that phrasing. Joy can smell Parkinson's disease. They are actually using the claim in the response. So step number 1, when you decide, is there convincing evidence? I'm actually going to highlight that convincing evidence phrasing too. When you are determining, is there convincing evidence, the first thing that you do is make sure you know what the claim is so you can use it in the response. Now this part is the actual response. When you get this on your quiz, because you are going to get one of these on your quiz, this is what they're looking for. This is to help you get on the right track, but this is the actual response. And you can frame all of your responses with these sentence frames. So, based on the dot plot, there, I believe that is not, I just want to make sure. Oh, there is, sorry. There is convincing evidence that Joy can smell Parkinson's disease. So based on our dot plot, there is convincing evidence because none of us were able to do it. And if we add on last class periods, that would put us at 41. There is convincing evidence that she really can smell it because 0 out of 41 of us were able to do the same thing that she did. So that's the next blank. So we're going to say 0 out of 16 trials. Is that what I put there? My thing fell out. In our class, we're able to correctly identify 11 shirts by guessing. It is plausible Joy can smell Parkinson's. So the question is there convincing evidence? And the answer is yes, there is convincing evidence because none of us was able to identify 11 shirts. So it is plausible. Yes, Allie? Plausible means that it is possible or believable. And that is a word that you use often in stats. You use the word plausible often in stats. It means it's believable or it's possible. Are you guys okay on that response? So we did the simulation to gather evidence to support her claim or to be able to reject her claim. Do you feel okay about what we did? 1 simulation, 16 trials. Y'all are good on that? Okay, we're gonna do 1 more simulation and evaluate 1 more claim. And that's what you need the other things in the cup for. So you have in your cup pink papers and blue papers. I want you to fold them up into 4, like half, half. Fold them all up like that. You're gonna need like 1.5 minutes. So take your papers, fold them up like so. Do you know what you're doing? Yes. Okay. You're folding up your papers. They're on the doc viewer if you're wondering. Oh, this is supposed to go to that lady too. Okay. Did you find your office?
No, I asked Brittany, and she said, I don't know what I packed it for, so I'll put them with packages. I said,
Great.
thanks for me.
Hey, you were able to get them in.
You just put them, put them the other way.
Oh, I see. Thanks, Shells. That's your good problem solving skills, babe.
I had a good teacher.
Oh yeah, that's me. That was
That's me. It's honest.
you want some M&Ms?
Let's see, is there any other jobs that I was...
Okay, about another minute.
What's your one day tomorrow?
Stats. Oh yeah, send me. Uh-oh, I think you guys might need more than a minute. Some of you guys are being very careful about your folding. That's good. I appreciate your carefulness. I wonder what the people at home are gonna do. Hopefully they'll just fast forward, right? What are you yelling about, Sal? What? Casey cut them. I told her that they had to be identical. If any of them got jacked up, we had to throw them away. Okay, I think we're really down to a minute. It's looking like most people are finishing up. Okay, while you guys finish folding, I am going to read you the setup for this problem. So you finish folding and I'm going to read you the setup. So this activity is investigating hiring discrimination. So an airline has just finished training 25 pilots. 15 are male and 10 are female. They're training to become captains. Unfortunately, only 8 captain positions are available right now. Airline managers announced that they would use a lottery to determine which pilots will fill the available positions. The names of all 25 pilots will be written on identical slips of paper. The slips will be placed in a hat, mixed thoroughly, and drawn out one at a time until all 8 captains have been identified. So as I was walking around, Allie had mentioned how nicely the papers were cut. And the reason why they were cut that way is because of the setup they're describing in this problem. When you do things like draw names from a hat, you have to make sure that your slips of paper are identical, so cut the same size, the same weight paper, all of that stuff. Your papers should be the same color, but they're not. I split them out in between pink and blue so that you could easily identify the 2 different genders. So that means that you had 15 blue papers and 10 pink papers. Does that make sense? Okay, so the people who are selecting the captains place them in a hat. A day later, the managers announced the results of the lottery. Of the 8 captains chosen, 5 are female and 3 are male. Some of the male pilots who weren't selected suspect that the lottery was not carried out fairly. One of these pilots asks your statistics class for advice about whether to file a grievance with the pilots' union. The key question in this possible discrimination case seems to be, is it plausible or believable that these results happened by chance? To find out, we are going to simulate the process that the airline managers use. So remember, simulate means we are going to do something similar. So before we carry out our simulation, one of the most important things to identify is, what is the issue? What is the issue? So before we write it in, while you guys are finishing folding or just waiting, I want you to take 30 seconds and see if your own brain space, if you can identify what the issue is. So it says, if the lottery were fair, we would expect. What do you guys think comes next? Give you about 15 more seconds to think about it. About 10. Does anybody want to share? Does anybody have an idea? Ivani? Perfect. So what is the issue? What would we expect? Well, if they're training 15 male and 10 female pilots, you would expect when they do the lottery that you would end up having more male captains because there were more males in the training group. So that's what we're going to write here. We're going to say, if the lottery were fair, we would expect more men to be selected than women because, this because is one of the most important parts, there are more men in the training group. If the lottery were fair, we would expect more men to be selected than women because there are more men in the training group. So based off of that issue, we are now going to simulate the process. So you're going to put all of your folded papers in your cup. I have hats for this, but we can't share hats. Sad day. Ivani, you have on another lovely pair of shoes. And then you're gonna try to shake it up as best you can. And you may wanna shake it, like pull some out and shake it more. So how many slips of paper are you gonna draw out without looking? 8, because there are 8 captain positions. So maybe you're gonna pull 2 and shaky, 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 shake, shaky, shaky, and then pull 2 more. And then shake, and 2 more. And once you have all 8, you're gonna count up the number that are female. So you're gonna count up the number of females. So you pull out 8 slips. Once you pull them out, count up how many are female. Okay, so on my first trial, I only got 2 females. Once you have that, do it again. Put all your slips back in, shaky, shaky, shake, and do the simulation one more, or do the trial, or do another trial. That's what I should say. Shaky, shake, shaky, shake. Done? So by the time you're done, you should have 2 separate trials. Let's go about 30 more seconds. About 10. Okay, so as you're finishing up, it says on the next page, create a dot plot and record each of our trials. So I'm going to flip this over, and the first thing that I'm going to do is label my axes so that I know how much room I have. So at the very bottom, like above number 4, I'm writing number of females chosen or selected, whichever word you prefer. Then I'm going to leave a little bit of space, and I'm going to start my number line. So the first possible option is that 0 females are chosen, or 1, 2, 3, 4. How far do we go? Well, how many captain positions were there? 8. So is it possible to choose 10 females? No. So we stop at 8 because that's how many captain positions are available. So our options are 0 to 8. The least amount we could choose is no females, and the most we could choose is 8 females. Then up here, before I put any dots down, I'm gonna clarify that what this is one simulation with, this time we're gonna have 32 trials. Because we had 16 last time, but then everybody did this twice, so it should end up being 32. Okay, we can put down mine first. So I had 4. Let me double check. I had 2 and 4. So 2, 4. Okay, Cheyenne. 4, 5. Amy. 2, 1. Priscilla. 5 and 5. Bryn. 5 and 5. Georgia. 2 and 3. Liz. 1 and 5. Osvaldo. 2 and 2. Brooke. 3 and 6. Grant. 4 and 3. Aiden. 3 and 6. JJ. 3 and 4. Allie. 3 and 3. Haley. Say again. 3 and 4. Ivani. 3 and 3. Aaliyah. 2 and 4. Did I get everybody? Okay. So now we answer the question. Does it seem believable that airline managers carried out a fair lottery? What advice would you give? So let's do a little bit of highlighting here to make sure that we address everything that they want from us. So the first thing that they want us to say is it believable? The second thing that they are looking for is, what advice would we give the male pilot? So our response has to include, is it believable, and what advice would you give? So what were their results? How many females did they select? 5. Okay, so I want to find out how many of our how many of our trials were 5 or more. So when you are doing a simulation and you're looking at dot plots or trials, you want to look at the number that was selected and higher. So for Joy's, we would have looked at 11 or more, and for this, we're looking at 5 or more. So we're going to count up the dots that 5 or more females were chosen. So 1, 2, 3, 4, 5, 6. I'm getting 8. How about you guys? So 8 out of 32, which is 25%. What we just found is the probability. So I'm going to say capital P with parentheses. We just found the probability of 5 or more females chosen. Why are we choosing 5 or more? Because that was the result of the lottery that the managers did. So this, the male pilot who is concerned that the lottery wasn't fair, he's concerned because 5 females were chosen. So that's what we base our response off of. So the question then is this plausible or believable or possible? So in statistics, if you're talking about the word plausible, your benchmark is 5%. You will have data, you will have observations, or you will have trials, and you will be able to count up the number of dots that are the same as what the claim is, or the results of the experiment you're doing. And if 5% or more are the same, you say it's plausible. So we got way more than 5%. We got 25%. So that means that it is plausible that the managers would have chosen 5 or more females just by chance. Does that make sense? Okay, so now let's translate that to our response. Now remember, our response always has to be based off of the claim. So the claim is that the lottery was fair. Meaning there was no funny business. There was no looking at the slips of paper. They shook it up. They didn't do anything to manipulate the results. They literally put the slips in a hat, shook the hat, didn't look, drew them out. So this is our actual response. Remember, you don't have to always write what is the claim. So the response is based on the dot plot above. It does seem believable that the airline managers carried out a fair lottery. So notice up here I highlighted, does it seem believable? That's the first thing that I addressed in my response. So maybe I should highlight that the same color. It does seem believable. And then after you address the question, you give your reasoning. So the next blank would be 8 out of 32, or 25% of our trials resulted in 5 or more females being selected. So you address the question and then you say why, using your numbers from the dot plot. It is plausible the lottery was carried out fairly, so I would advise the men not to file a grievance. And then I'm going to highlight that in my second color. So up here it says, what advice would you give? So I would advise the men not to file. And as you're writing that down, I just want to reiterate what we're doing here. We are investigating a claim, and in order to make a conclusion, we need to have evidence. And this dot plot is our evidence. Do you guys feel okay about that? Okay. The one other thing that I want to highlight before we move on is this benchmark. For the whole year, not just in this lesson, for the whole entire year, If it's ever asking you to evaluate a claim or talk about convincing evidence, your benchmark is always 5%. Okay, so the last question on this, number 5. Would your advice change if the lottery had chosen 6 female and 2 male pilots? Well, let's just quickly find the fraction. So if I come up here, 2, so that's 2 out of 32. And I'll change that to a percent for us. That is 6%. And then let's look at 7. How many were 7 or more? 0 out of 32. Okay, so would our advice change if we had chosen 6 females? Would our advice change? No. So I'm going to circle this, and I'm going to say no. And then I'm going to use the paragraph below for the 7 females. So if 6 were chosen, our advice would not change. If 7 were chosen, would our advice change? Yes. So that's what we're going to put in this answer sentence frames. So we're going to say yes. Our dot plot shows 0% of our trials resulted in 7 or more females being selected. I think I'm going to highlight that so that I don't forget if I come back to these notes which one of these I used. So what about 7 pilots? Yes. Do you guys see what I did there? So I want to be able to remember if I come back to these note sheets to study that what I did here was this guy is a no, but then this one is what I used the sentence frames for. It is not plausible the lottery was carried out fairly. So I would advise the men to file a grievance. How are you guys feeling? Are you feeling okay? Yes, Georgia. It's up to you. I didn't, well, I guess you could go through and highlight both of them again. So if you want to do that down here, you could. What I focused more to highlight on this problem was just to make sure that I would remember that I did this answer for 7 or more females. But it's up to you, whatever you think's gonna help you the most when you come back to these. Okay, so that's 2 examples of us evaluating a claim. So now we're gonna see how well we understand this. Now before things get too far away, we still have about 10 minutes left in class. I'm thinking that the only thing you'll need to do on your own is number 3. We're gonna do number 1 together. I'm hoping you'll have time to try number 2 before you go, which means you will do number 3 on your own. So hopefully the only thing you have between now and Wednesday is number 3 and counting up your M&Ms. You're okay there? Okay. So this setup is a little bit different. We're going to evaluate a claim, but this time instead of doing a simulation, what we have is a sample. So we're not doing anything. We're just going to go and observe things. So the setup for this one is you would like to buy a used car and have chosen a Ford Focus because you heard most of them get great gas mileage. There is one for sale on KSL for $4,000 and the owner claims he gets 41 miles per gallon. I'm going to highlight that right now. The owner claims he gets 41 miles per gallon. If it ever says the word claim, that's going to help you out a lot. A sample of Ford Focuses was taken. The dot plot shows the fuel economy in miles per gallon for those cars. So what they mean by a sample was taken was they were able to find the miles per gallon for 160 different Ford Focus cars. So we don't have to do a simulation here. We can just go and find a bunch of Ford Focuses and ask what their gas mileage is. Does that make a little bit of sense? Okay, so what is the claim? The claim is that the Ford for sale gets 41 miles per gallon. The higher one. So that means that you can drive 41 miles on 1 gallon. So like Man's Jeep gets 18 miles per gallon. His is way worse. Does that make sense? Okay. So down here, if you counted up all these dots, and I was going to make you do it, but we're getting so close to the end of class that I'm not going to make you do it. If you counted all of them up, this is 160 dots. This is 160 dots. Then underneath, you have the framework of what you should include in your answer. So this is not the answer. Down here, you use these to write the answer. So the question is, do you believe the owner's claim? So what we're answering is, yes, we believe it, or no, we don't. So let's look at our dot plot. How many of these get 41 or more? 2. 2 out of 160. So I drew on my dot plot a line, and that would be like where 41 is. Only 2 cars get 41 or more. So I'm going to start with based on the dot plot. Do we believe or do we not believe? No. I do not believe the owner's claim. So that's 2 of the bullet points. Based on the dot plot, I do or do not. Now we have to write because and actually give the numbers from the graph. Because only 2 out of 160 or 1% of, and then this is an important part, of the sampled cars got 41 or more MPG. That's the 10-minute bell. I mean, is that the 5-minute bell? That's the 5-minute bell. Okay, so I'm highlighting before I finish this up the phrasing of the sampled cars, because in the last 2 examples we said 2 out of 160 of our trials, but this was not a simulation, this was a sample. So instead of saying trials, we have to say sampled cars. So let's make sure we're hitting all of our bullet points. Based on the dot plot, I do or do not, because, and now we end with a sentence that says it is plausible or it is not plausible. It is not plausible that the Ford Focus gets 41 miles per gallon. I feel 100% confident you will be asked to answer a question like this on the AP exam, and you will get one of these on your quiz in 1 week. Do you feel okay here? Okay, I want you to try number 2. You might not have enough time to get fully finished, but I at least want you to try it. The University of Utah published a fact sheet stating that Utah has the largest average household size in the nation at 3.19 persons per household. So that means 3 people living in a house. A sample of 50 households was taken. So I'm gonna note that this is another sample. This is not a simulation. The dot plot displays the results. Do you believe the U of U's claim? So the University of Utah published a fact sheet that household size is 3.19 persons. So that is the claim. I'll find it, Shells. Don't worry. This is my whole life. Oh, did I ever come get your buttons? I'm gonna come get that now while you guys. Oh, Shelby's gonna come grab them. Okay, finish this up and we'll check it next time, yeah? Okay. Person 1 cleans today.
You have a rug for my whole station.
Yes. Ian? What's up? Yeah, he went home. Trip was sick.
There was like no.
Yeah, he had to run home because Trip had to go home from school early.
See you this morning.
Okay, love you. Thanks for your help, babe.
No problem.